So, new topic for heat transfer. This will be the last one. So, heat exchanger. So, what is a heat exchanger? Okay, yung mga kotse nyo, okay? Makita nyo yung nasa unahan na gawa sa aluminum. Yun ay yung parang nagpa-pass through, nilalagyan nyo ng tubig. Diba? Kapag sobrang init, nag-overheat na, nilalagyan nyo ng tubig. That is what you call a heat exchanger. Radiator, tawag nyo doon. That is a type of radiator. That is a type of heat exchanger. Yung ano nyo, yung likod ng inyong refrigerator, meron yung heat exchanger. Okay? Yung mga boiler, mga heater, okay? Kahit yung yung mga aircon nyo, may heat exchanger yan. Okay? But what is a heat exchanger? Generally, it is any device which affects the transfer of heat from one substance to another. Ibig sabihin, if you have a working fluid, okay, one that is absorbing much of the heat coming out from a system, and another, when it came in contact with that hot fluid, it transfers, or the hot fluid transfers its heat to that cold fluid, okay? Yan yung purpose ng ating heat exchanger. Para yung ating circulation nung fluid inside a hot body, okay, makuha niya yung init at makondisyon niya yung init nun. So, what are the common examples of heat exchangers? Yung steam boiler, okay? Steam condenser, water heaters, oil heaters, evaporators, economizer, fluid heaters and coolers, tube banks. Ngayon, itong mga to, some of them na nahawakan ko na na-operate ko na nung ako'y nasa power plant. Ngayon, ang common heat exchangers namin na charged air, tinatawag doon charged air cooler, ibig sabihin, coming from malaking diesel engine. Yung engines natin, in order to produce work, it uses heat, okay? Heat coming from what? Heat coming from the fuel or a heat source. So, pag nagkaroon ka na ng heat exchange doon, yun dapat na ipapasok mo na hangin doon sa iyong engine, di ba? Sabi ko dyan, sa combustion, in order for you to produce fire, you need what? Air, fuel, and then energy or a spark. Ngayon, pag nagkaroon nun, continually, magpuproduce ka ng heat, and then yung heat na yun, yun na magpuproduce ng work dun sa engine mo. And yung heat na yon, overtime, yung engine mo nagbi-build up ng heat. Okay. At optimal heat, at optimal temperature, your engine will produce its maximum work. Ngayon, kapag nag-overheat ang engine mo, hihinto yan at hindi na niya mapoproduce yung attainable work na kailangan niya. Okay? What should we do? Ngayon, syempre, kailangan natin siyang lagyan ng cooling system. Yung cooling system na yun, dyan papasok yung heat exchangers. Yung cooling systems na yun, kung makikita nyo, yun yung meron kayong mga nasa talyer, mga malapit sa talyer dyan, silipin nyo yung mga engine block. Meron yung mga butas dun sa kanyang engine block. Ano pong purpose nun? Ang purpose nun is to make sure na yung engine mo hindi iinit. Bakit, sir? Dun nagpapasok yung mga tubig coming from your radiator. Where your radiator, papasok doon yung mainit na tubig, at kapag came in contact with cold air, magkakaroon ka ng heat exchange. Okay? Tatanggalin yung init doon sa tubig mo nung hangin na magpapaso doon sa radiator mo. Another one, okay? Kung matutulin na kotse, kailangan ng mga turbo. Kailangan mo ng mga intercooling devices. Okay, another type of heat exchanger yan. Ang ginagawa nun is pinalalamig niya yung hangin na ipapasok mo dun sa engine mo. Ang engine mo, hindi yan magkakaroon ng combustion kung walang hangin. Yung mga charged air coolers, intercoolers, yan ang ginagamit natin para palamigin yung air that your engine will suck. Yung hihigupin niya going to your cylinders. Okay? Ganun po yung purpose ng heat exchanger. Ngayon, sa mga refrigerator naman natin, yung mga condenser. Okay? Yung mga condenser natin, nagkakaroon tayo ng heat exchange dyan. ano nangyayari? So, yung superheated vapor na ng freon, mangyari is kukunan mo ng init when it came in contact with the flowing air. Ganun nangyayari sa condenser. Ngayon naman, kapag malalaking refrigeration system or units, yung condenser mo, meron kang ginagamit na cooling air, pwedeng charged air, pwede rin naman commonly, that is, kung di ako nagkakamali, cooling water coming from your cooling tower. Diniscuss ko na yan sa refrigeration. Yung cooling system mo, okay, dun sa iyong refrigeration system, gagamit ka ng condenser para magkaroon ka ng heat exchange with the use of a cooling medium. Ang ginagamit mo is cooling water. Now, yung cooling water mo, iinit yan gradually. At pag uminit yan, gagamitan mo ng cooling tower. Ngayon, yung cooling tower, nagkakaroon ka doon ng evaporative cooling, kung saan yung hangin na magpapasto doon sa iyong cooling tower, yan yung gagamitin mo para palamigin yung circulating water inside your condenser or chiller system. Okay? There are different classifications of heat exchangers. So, let us go here. Yan, ayaw gumalaw. So, meron tayong number 1, heat exchangers wherein fluid at a constant temperature gives up heat to a colder fluid. Ibig sabihin, common dyan na yung hot side mo, this is the hot side, and then cold, commonly, hindi nababawasan yung init. Yung heat exchanger mo, nagsusupply ng init. Ibig sabihin dito, gives up heat or supply lang siya. Nagsusupply lang ng init. Okay? Hindi nag-absorb ng init. So, yung nag-absorb ng init mo, siya yung tumataas. So, from here, constant yung temperature niya. Temperature here is constant. Okay? Yung hot side, constant. Okay? Dito nagbabago gradually. Where you can you can measure the maximum and then the minimum change in their temperatures. The temperature of which gradually increases as it flows through the device. The heating fluid can be at rest or moving in any direction. An example of this type would be a steam condenser. Okay. Another one, devices wherein a fluid at constant temperature receives heat from warmer fluid. So ito naman, nag-a-absorb ka. Yung cold body mo, constant. Ina-absorb lang niya yung ina-absorb nung hot body mo yung nagpapa-absorb ka nung heat. Ibig sabihin, bumababa yung temperatura mo. Okay? Asan dito yung fluid that moves? Okay? Fluid at constant temperature, ito yon. Receives heat. So, ang heat mo, ibinibigay mo dito. Pababa. Okay? Yung heat. So, dito, from hot side, gradually, magkakaroon ka ng change in temperature here. Okay? Pababa. So, meron ka ring maximum, meron ka ring minimum. Parallel flow. So, parehas sila coming from. Yung isa, malamig. Ito, mainit. Okay? At pag nag-pass through sila and came in contact with, yung isa will give off heat, yung isa mag-a-absorb ng heat. Kaya gradually, iinit yung isa at yung isa iinit din. Nawawala yung kanyang coldness. Okay? So, malaki yung kanyang maximum, maliit yung kanyang minimum. Okay? Example of this type are water heater, oil cooler, and coolers. So, number 4, counterflow heat exchanger. Ibig sabihin, magkaiba ng flow. From one side to the other, from the hot side to the cold, yung isa naman from cold side to the hot side. Okay? Cross flow sila. So, possibly the most favorable kind of fluid heaters and coolers. Okay? Yun yung counterflow or cross flow. So, this is the T-min, T-max. Titignan mo muna yung kanilang difference. So, dito natin malalaman, there are two types of temperature difference here. The logarithmic mean, and then arithmetic mean. Okay? Logarithmic mean, gagamit ka ng natural logarithm para makuha mo yung kanyang changes. Sa arithmetic mean, just the mean or the sum of the maximum and minimums. Okay? Note, if the temperature difference delta T max is not more than 50% greater than T min, the arithmetic mean difference will be within 1% of the limited logarithmic mean temperature difference and may be used to simplify calculations. So this is from the principles of heat transfer, the fourth edition by Kirth and Bond. Kirth and Bond. So ayan, meron tayong mga example here. Ayan, pwede natin gawin ito. So, meron akong na-prepare dito. Mas magandang yun yung ating solve. So, for problem number 1, in order for us to understand yung ating heat exchangers further, mas magandang sinosolve natin yung mga problems like this one. So, parallel flow, cross flow, or counterflow. Ayan, dami kong mga example. So, liquid to liquid counterflow. Okay, counterflow heat exchanger is used to heat a cold fluid from 120 degrees Fahrenheit to 310 degrees Fahrenheit. Assuming that the fluid enters at 500 degrees Fahrenheit and leaves at 400 degrees Fahrenheit. Calculate the log mean temperature difference of the heat exchanger. So, LMTD. The best way for us to understand it is to draw. But first, tandaan natin dito ang nangyayaring heat transfer is convective heat transfer. Or, simply the heat transfer, okay? The general heat transfer that is given by UA. Okay? UA delta T. Where U is the overall conductance, A is the area projected. And delta T could be, number 1, LMTD or AMTD. Depende kung ano ibibigay na condition sa iyong problem. Now, okay? Dito, mas maganda kasi, ay pag graph mo, i-measure mo muna yung delta T kung nasaan yung maximum and minimum. Siyempre, sa pagdodrawing, makikita mo naman that this is delta T minimum. Okay? Yung minimum difference. Ito naman, delta T. Okay? Delta T maximum. Kasi ang laki ng difference nila. Okay? Dito, alamin mo muna, isolve mo muna yung delta T nung bawat isa. Okay? Bawat side. Para malaman mo kung ano yung may mataas na difference at yung mas mababang difference. Okay, to recall, AMTD, that is equal to delta T max plus yan parate. Delta T minimum over 2. That's AMTD. How about LMTD? MTD. Madali naman tandaan yan. LMTD. Delta T maximum minus delta T minimum divided by natural logarithm of the ratio ng delta T maximum over delta T minimum. Yung dalawa lang naman ang tatandaan mo. So, mas maganda i-solve natin yung problem by drawing it. Okay. Ang conditionis mo dyan ay always ganito. Gusto ko to. So, there is a temperature rise and fall within the length of the heat exchanger. So, ang consideration mo dito is the temperature and then the length ng iyong the length of your heat exchanger. Now, ano magmumula dyan? 500 and 400 sila yung mga pinakamataas. So, tignan natin. This is 500. Yung 400 nandito. Okay natin. Tapos ang susunod dyan ay 300, 10, tsaka 120. So, dito na lang natin yung 310. Tapos, nandito yung 120. The problem there, that is cross flow. Okay? So, ano nagbibigay ng init dyan? Ano nagbibigay ng init dyan? So, from hot fluid enters. So, the hot fluid papunta rito. Hot fluid. Yeah. Kurba. So, this is 500 degrees Fahrenheit. This is 400 degrees Fahrenheit. Tapos, cold fluid to hot. Nag-absorb siya ng init eh. Okay? Yeah. So, this is from 120 degrees Fahrenheit to 310 degrees Fahrenheit. So, measure natin yung delta T max at delta T min. Hindi natin ma-determine saan yung delta T max at delta T min. Tignan muna natin. Okay. 500 minus 310. 190. 400 minus 120. That is 280. Ibig sabihin, ang T max mo is 220. Okay? Very basic. So, this is, ang delta T here is 280. Ang delta T here is 190. So, alam mo na, this is maximum, this is minimum. Okay? Pero dito, unahin mo po yung pinaka mainit tsaka yung pinaka malamig. So, dito, okay. LMTD ang hinahanap. So, LMTD, yun natin. Unahin mo na yung pinakamataas na temperature. Sir, ba't hindi mo sinunod yung delta T max, delta T min? Simple, okay? Pinakita ko sa inyo na malilito kayo dyan kung anong gagamitin nyo. Okay? Tignan nyo hindi mahalaga, papakita ko sa inyo, hindi po mahalaga na maximum ang kanyang difference at minimum ang kanyang difference. Ang sundin mo parate yung merong pinakamataas na temperatura. Okay? So, 500 minus 310, papakita ko sa inyo mathematically minus 400 minus 120. Divided by ln. Yung 500 minus 310 over 400 minus 120. Tignan nyo ito. Itong baba lang Kapag ang divisor mo negative, may negative lahat yan. Tignan mo. Logarithmic. Okay? Natural logarithm nung 190 divide by 280. Tignan nyo, negative yan. Okay. Paano kung 280 over 190? Diba positive? Wala pong LMTD na negative. Okay? At AMTD na negative. Dapat yan positive. So, ang babasihan mo dito, mathematically, ito, 190 na to. Ito is 280. Dito sa taas, makikita mo naman Diba? This is 190, this is 280. Ngayon, ang magiging sagot mo dyan, dapat positive. Wala pong value ng LMTD and AMTD na negative. Okay? Kahit ma-determine mo na na delta T max, delta T min. Okay? Hindi po ganun yun. Nilinaw ko lang po. So, that is 190 minus 310. Kasi ito, 190 minus 310 tuloy, 190 minus 280, di ba negative? And then yung divisor mo negative, di ba naging positive siya? Tama ba? Algebraically, mathematically, malilalaman nyo na that is positive. Okay? The LMTD value there is LMTD value, ano po? That is 232.0991 degrees Fahrenheit. Sir, paano naman kapag AMTD? So So, the AMTD value, 500 minus 310 plus, walang problema dito, 400. Ang problema mo dyan parati, LMTD, minus 120 over 2. So, I think this is 190, 280. Divide mo lang ng 2. 190 plus 280. Divide by 2. The answer is 235. 235 degrees Fahrenheit. Very basic lang po ang heat exchangers. Next one. Okay. So, heat exchanger has an overall coefficient of heat transfer. So, this is U. Of watt, 900 watt per meter square degree Kelvin. The mean temperature difference is 20 degrees Celsius and the heat loss is 15,000 watts. Calculate the heat transfer area in square inches. So, this is given by Q, U, area, delta T. Ang hinahanap mo dito is area. So, balik tayo. Reform na natin. Area is equal to Q divided by U delta T. Meron na tayong Q. Okay? Area is square inches, ha? That is 15,000 watts divided by U. 900 watt per meter squared degree Kelvin. A change in temperature there is 20 degree Kelvin na rin yan kasi change in temperature. Anong hinahanap natin? Yung area in inches squared. So, we cancel all the same units. Watt, in degree Kelvin. Aakit yung meter squared. Okay? So, magiging meter squared. There are ilang meters per feet. Okay? Times. So, you have aakit to meter squared. So, kailangan ma-cancel. 3.28 feet per meter. Kaya lang square mo. And then, there are ilang feet per inch. So, you have 12 inch in 1 foot. Yung cancellation of units, square mo din to kasi naka-square din yung feet dito. You cancel again the same units, yung meter squared, yung meter squared, yung feet squared, yung feet squared. Ano tira is inches squared. Now, we can calculate. So, 15,000 times 3.28 squared times 12 squared, that is 144. Hindi ako nagkakamali. Divided by 900 times 20. The answer will be 1,291.008 inches squared. So, the area is 1,291.008 inches squared. Very basic in problem number 2. How about problem number 3? So, problem number 3. An economizer receives hot gas. So, ang CP ng hot gas is binigay dito. 0.27 BTU per pound degree Rankine and water in the ratio of 1.5 gas, 1.5 pound gas per 1.5 pound water. Basic yun. The gas enters at 845 degrees Fahrenheit and leaves at 352 degrees Fahrenheit. The water enters at 120 degrees Fahrenheit. Find the X temperature of the water and the LMTD for the parallel flow. Parallel flow, ha? If there are no external energy losses. So first, I want to find the temperature change of the water. Paano natin gagawin yun? Di ba, ang pinag-uusapan natin dito is the heat transfer due to convection. So meron tayong heat transfer coming from gas and then heat transfer coming from water. So, ano to? MCP ng gas mass ng gas, delta T sa gas. So, ayan o, gas enters. So, water, hindi natin alam yung exit temperature ng water. Siyempre, iinit yan. Okay, dito natin, mass ng water, CP ng water. Ito, constant to, kahit hindi natin ibigay ito ha. Anong CP ng water? Kapag English unit, di ba 1 BTU per pound degree Rankine? Oh, take note of that, hindi dapat makalimutan yan. Okay, we reform the equation. Dito yan. Yung binigay kasi sa'yo dito, the ratio of, ratio of water, ng gas to water. So you have the mass of gas per mass of water. Ratio yan. So we divide this all with the mass ng water. So makuha mo yung ratio nila. So mass of gas per mass of water multiply to CP ng gas, delta T ng gas equal to CP ng water, delta T ng water. We simplify. Okay? Dito natin kukunin eh. So, mg nung gas, m nung water, tapos divide natin CP ng gas, CP water. Ito. Simplify na natin. Tapos, delta T ng gas, T hot sa gas minus T low sa gas equal to T hot nung sa water, ito yung hahanapin natin, minus T low nung water. Sir, kailangan pa po ba natin i-absolute yan? No, hindi na kasi difference naman ang hinahanap dyan. Pwede na yun. So, mg, ito, meron ka na nito. Okay? Cancel mo na lang yung unit. So, 1.5 na lang. Yung CP ng gas, hindi ako nagkakamali, binigay dyan, 0.27. 0.27. Huwag na natin ilagay unit kasi cancelable naman yung unit dito. Tapos 1. T hot nung gas, that is 845 and 352. Okay. Degree Rankine na ito. Pwede rin, Fahrenheit na yan. Change in temperature lang naman. Degree Fahrenheit mo na lang. Equal to T hot nung water. Wala tayo niyan. Minus T low nung water. Ano yung T low ng water dyan? 120 degrees Fahrenheit. Okay. So, ilipat ko na lang sa kabila. Additive na yan. So, 1.5. Calculate ko na muna. Inauna. Let me calculate. So, 1.5 times 0.27 times 845 minus 352. Ayan. So, I have there, ito na, 199.665 degrees Fahrenheit equal to T hot ng water minus 120 degrees Fahrenheit. Just add yung 120 dito sa kabila. Add natin. So, T hot of water is plus 120 na lang. Okay, makuha natin yung kanyang value. 319. Hindi pa tapos yan ha. 319.665 degrees Fahrenheit. Okay. Anong hinahanap natin dito? Is find the exit temperature. Check na to. LMTD na lang. For parallel flow. So, i-drawing natin pag parallel flow. Tignan ulit natin yung heat exchanger. Nasaan yung parallel flow dyan. Okay? Parallel flow. Nandito yan. Okay? Yung binigay ko dyan. Parallel. Okay? Yung current, counter current. So, parallel, counter flow. Ito, parallel flow. Pareho sila ng direction. Andito. Concurrent. Hindi yan. This, co-current. Ayan. Pareho sila. Ito yung gagamitin natin. Parallel. So, we draw the figure. Sa gilid ko na lang. temperature, tapos length. Gamitin ko yung blue for the cold one. Nandito. Tapos, nandito siya. Yung mataas niya. So, this is the water side. Dito yung gas side na sa taas. Yung gas side dapat mas mainit. This is the gas. So, parallel flow or co-current. Yan. Co-current. This is the H2O side. This is the, ayan natin. H2O. This is the gas. Yung gas mo, 845 degrees Fahrenheit. Tapos, lalabas yan 352. Dito lalabas na 319.665 degrees Fahrenheit. Dito lalabas siya, papasok siyang 120. So for LMTD, okay, sundin natin parati yung may pinakamataas na temperature. So LMTD equal to yung 845 minus yung 120 minus 352 minus 319.665 divided by the natural logarithm nung ratio nila. Eight, 4, 5, 120, 352 minus 319.665. Okay. LMTD there is equal to 8, 4, 5 minus 120 minus. Dire-diretso ko lang 352 plus. Sir, bakit naging plus? Negative times negative, magiging positive. 319.665. Okay. So, natural logarithm. So, 845 minus 120. Tapos, 352 minus 319.665. The answer will be 222. 222.720. Approximately, gawin na lang natin 223 degrees Fahrenheit. That is for problem number 3. Very basic yan. Ito rin, very basic din. Another problem. So, I'll cut this off. Pagdating dito. Okay. Counterflow. Counterflow naman. Do-drawing lang naman kayo dito pag LMTD tsaka AMTD or heat, tawag dito. Magdo-drawing lang kayo pagdating nitong heat exchanger. Okay natin. Okay, drawing lang natin. So, meron kang binigay dito. Heat a cold fluid from. So, ini-heat mo yung fluid. Assuming the hot fluid enters at 530 and leaves at 360. Very basic yan. So, T, L. Okay, meron ka ditong hot fluid na 530, dito ka nagmula. Natapos at 360. Yung cold fluid mo, sabi dito, counterflow. Counterflow. So, yung mainit mo, nandito na. Okay? Diyan yung mainit mo. Tapos yung yung malamig mo dito galing. Okay? So, counterflow yan, magkaiba ng flow. Ibig sabihin, from here, aakit yung temperatura niya dyan. From here up to here, yan, lalamig to. Yun, counterflow nga eh. Ayan, yung kanyang arrow. So, labelan natin. If this is 530, this is 360. This is 320. This is 150. Counterflow. LMTD lang naman hinahanap mo. LMTD. Ano may pinakamataas sa temperatura dyan? 530. Minus. Yung difference dito sa dalawa. Okay? Okay ka, delta T. As dito, delta T ulit. So, 530 minus 320. 320 ba 310? And 320. Minus 360 minus 150 divided by lone natural logarithm nung 530 320 divided by 360 minus 150. Okay. Solve muna natin sila. May lalabas na value. So, 530 minus 320 minus 360 magiging plus, negative, negative, plus 150 divided by natural logarithm. So, 530 minus 320, I think that is 210. As 360 minus 150, 210 pa rin. Op! O, ano ang loan ng 1? Di ba 0? O, math error yan. Kasi ang loan ng 1 is 0. Ayan, pakita ko sa inyo kung paano natin gagawin dyan. If the difference here is 210, highlight natin. 210 yung difference dito. Delta T here. Okay? Yung delta T here din is 210. O, yung delta T rito, 210. Yung delta T dito, 210. The problem there, tandaan nyo, note. Okay? The natural logarithm of 1 is, try natin. Para makita nyo. That is, low ng 0. That is, undefined yan. Undefined to. Hindi to pwede. Okay? Anything that is divided by undefined value is null. Okay? Null. Wala siyang value. O, ang loan ng 1, undefined. Ang loan ng 10, 1. Hindi ako nagkakamali. Loan ng 10, that is 1. Tama nga. Log pala yan, sa log pala. Logarithm. Natural logarithm pala ang pinag-usapan natin. But loan of 1 is undefined, ha? Take note of this. Sir, ano pong gagawin dyan? Wala akong makuha value. Very basic. You do this one. Okay? For LMTD, gawin mo to. Kapag ganyan, nag-equal yung dalawang changes. So, lagyan mo dito ng 210.123 to the 10 thousandths minus 210. You know, una parate. Divide mo ng natural logarithm nung 210.0001. 10 thousandths of the decimal. Divide by 210. May makukuha ka pong value dyan. Let us see. So, 210.000. Kahit sumobra ng isang 0 yan, okay lang. Minus 210. Basta hanggang 5 hanggang 5 decimal places, pwede na yun. Loan of 210.1234. 5. Hindi 5 pala. 1 over 210. Okay lang yun. May makukuha pa rin value dyan. So, the value there is 210 pa rin. Very basic. 210 degrees Fahrenheit. Okay? Kahit sobrahan mo yan. LMTD there is 210 degrees Fahrenheit. Ganun lang po yung technique niya. Okay? Any questions? And if none, that wraps up our discussion for today. Okay? That will be all for heat exchangers. So I hope may napulot kayong bago and have a nice day.